So in this class we're going to just extend what you've learnt so far about graphs a little bit further. And you might have seen some of this before, so some of this in junior maths as well. So a planar graph. So the word planar, a planar graph, basically it's a flat graph. That's what it means. Planar graph is basically just a flat graph. Okay, as in we can draw it in 2 dimensions without crossing over. So on a planar graph, none of the edges intersect. The only places edges meet are at the vertices. So we can see here we've got 3 edges meeting at vertices C, we've got 3 edges there, we've got a couple edges there, and we've got 4 edges at B, but there's no crossing over. So there's no intersecting edges. So this is a planar graph. Okay. Sometimes a graph can be drawn in such a way that it doesn't look like a planar graph. It looks like a non-planar graph. But if we investigate a little bit further, we can change the way we draw it so it's a planar graph. Okay, so here we've got an intersecting edge. So we've got AD is intersecting with CE. Okay, so there's an intersection there. So it looks like it's a non-planar graph. But if we go and just change the way we draw it, instead of the D being out here, we put the D in here, then what happens is we can go from A, we can have all the same connections, all exact same connections, so it goes from A to D, and then the C to E, it goes around the outside, and so it is actually a planar graph. So these are the same graph. This is just drawn so it looks like a non-planar graph, but here we can show that it's a planar graph with none of the edges intersecting. So that's basically the rule for a planar graph. None of the edges intersect. Okay. Not all graphs can be drawn as planar graphs. So we've got an example here. This graph is a non-planar graph. This graph cannot be drawn as we cannot get rid of all these intersections. There's far too many of them to be able to just get rid of them by going on the outside. Okay, so we go from B to D on the outside and we get rid of these 2 intersections. Okay, and we can go from B to E on the outside and get rid of these 2, but we've still got to be able to go from E to C. So we can't get rid of all the intersections, so this one is a non-planar graph. Okay, so that's what a planar graph is. Okay, so an example here, redraw the graph that's shown here in planar form. So we've got to get rid of this intersection. So I'm going to draw my points A, D, B and C, A, B, C and D, and I'll draw the A to D in, that's fine. I'll draw the A to C in, that's fine. I'll draw the B to C in, that's fine. Now we've got to get a line that goes from B to D without going across the middle, so we're going to go around the outside. And now that is a non-planar graph. That is a planar graph, sorry. Okay, could have gone around that side as well. So not everyone's is going to look the same. Okay, now something new that we want to talk about are the faces of a graph. Okay, and so this starts becoming more important when we start talking about nets as opposed to networks. So the faces of a graph are the different regions that are bounded by the graph. So here we've got A, B, C, and back to A, and we have this region F1 is bounded, but we've also got this outside region, and there's always going to be the outside region. Okay, so here we've got the graph is basically the edges, the blue lines, And what we've done is we've colour coded the different regions or faces. So we've got face 1, face 2, face 3, 3 different regions inside the graph, and then we've got the outside region. So this one has 4 faces. This one has 2 faces. Okay. If I was going to draw something like this, this would have 1, 2, 3 faces. Okay, 1, 2 inside and the outside face. Okay, so and the outside face, as it says here, is an infinite face. It's got an infinite size because it's everywhere outside the region. So if you think of Wonthaggi, Inverloch, Cape Patterson, there is a face, there's a region in between there, it's all bounded, and there's a region on the outside. It goes on forever, includes the rest of the world. Okay, so we call that an infinite face. Okay, here we've got we're going to introduce Euler's formula. E-U-L-E-R. We actually pronounce it Euler. So Euler's formula. Euler discovered that for connected planar graphs, there's a relationship between the vertices, the edges, and the faces. Okay, so this is only for planar graphs. So the number of vertices minus the number of edges plus the number of faces is always equal to a constant 2. Okay, so V minus E plus F equals 2. So if we have a look down here, the number of vertices on this one, V, so there's 1, 2, 3, 4, 5, 6 vertices. The number of edges, so the edges are between each point, so there's an edge. 1 edge, 2 edges, 3 edges, 4 edges, 6 edges, 7 edges, 8 edges. So there are 8 edges in this one. Let's just count them again. 1, 2, 3, 4, 5, 6, 7, 8 edges. Okay, the lines between the vertices are edges. And the faces, 1, 2, 3, and the outside face is 4. So let's just check it. 6 minus 8 plus 4. 6 minus 8 is negative 2 plus 4 is 2. It works for Euler. Euler's formula works. We can confirm it works for this graph. Okay, so this example, consider the connected planar graph shown. Okay, write down the number of vertices, edges and faces. So let's start off. Vertices 1, 2, 3, 4. Okay, A, B, C and D, and 4 of them. Edges 1, 2, 3, 4, 5 and 6 edges. Check it, 1, 2, 3, 4, 5 and 6. And faces, so we're going to go 1, 2, 3 and the outside one is 4. So let's just check. V minus E plus F equals 2. So we're going 4 minus 6 plus 4 equals 4 minus 6, negative 2 plus 4 is, once again, it's 2. Okay, so that's part B. We've verified Euler's formula. Okay, now this example we're going to use Euler's formula to find a number of faces of a graph. So a connected planar graph has 4 vertices, 5 edges. Find the number of faces. So we've got V minus E plus F equals 2. So we've got 4 minus 5 plus F equals 2. 4 minus 5 is negative 1 plus F equals 2. Okay, I'm going to plus the 1 to get rid of it. Same to the other side, and I get F equals 3. So it has 3 faces. Okay, and let's just check it. 4 minus 5 is minus 1, plus 3 is 2. Okay, let's just have a go at drawing it. 1, 2, 3, 4 vertices, 5 edges. 1, 2, 3, 4, 5. And so it's got 1, 2, 3 faces. Okay. So, your exercise today, exercise 9D. Exercise 9D is on pages 428 and 429 of the book. Make sure you're doing the tick sheet questions, and if you need any help, just ask for it. Okay? I'll talk to you in the chat, otherwise I'll catch you next time.